This is Mr. Kanaar from Saginaw High, and we're going to go over Chapter 7, Section 5. I call this Part B for this episode. Sorry about the last episode, guys. If you were watching 7.5a, I started running out of time, so the last problem I kind of had to go through quickly. If I have time on this, I might go back and show you the way to do the last problem that was in the last section. So let's look at the problems that we had to do here in class. So we did 26 through 34. And in that problem, we write each expression in the exponential form. So we're going from radical form to exponential form. Okay, and then 37 through 42, we're simplifying the expression using the properties of exponents and then writing the expression in radical form. So let's look in my little book here that I keep with how to do each problem. We have page 451, 26 through 34, and 37 to 42. So 26 here, we have the fifth root a cubed. And you want to remember what your root is. It goes in the denominator for the exponent on the exponential form, and the power goes to the numerator. So this is a very easy one. You have a to the 3/5 power. Number 27, you see that's in parentheses, so I have to make sure that I do everything to each variable and also the constant, which is 2. And I can also see right off the bat that 4 over 2 can be simplified to 2, okay, which just makes that the square. So I have 2c, and then the whole thing's in parentheses squared. So I'm going to have 2 times 2, which is 4, and then I'm just going to keep the variable as c to the second power. Now, when I come down here, I have a radical form, and in order to do the radical form, I have to have the fourth root of 256a cubed. Now, I'm going to take the constant part first. I'm going to find the fourth root of 256, which happens to be 4. You can check it on a calculator if you want to. And then I have a to the third power, so I'm going to do that part separately. So it would be the fourth root of a to the third power. And I end up taking a to the 3/4 power. So I'm taking that radical form, and I'm going to the exponential form. Sorry if I say rational by accident. There was a bunch of problems that we did earlier, and I think I made that mistake too. The chapter had rational and radical, and I may have made a couple mistakes, so I apologize if my vernacular was not correct. Here we have the cubed root of 8x squared, and because we have the 8x in parentheses, I have to make sure that I include that second power. So I rewrite it in an exponential form of 8, 2 to the third, and x 2 to the third. I can see that I can simplify the 8 with the cube root. The cube root of 8 happens to be 2, and then I'm going to square that, and you can see my work. And I end up getting 4, x to the 2/3 power. Okay, number 30 is the same type of thing there, but the square is not included in the 27. So I only get the cube root of 27, which I can see is 3. And then I'm going to write the exponential form for the variable, which is c, 2 over 3 power. So it's 3c, 2 over 3 power, 2/3 power. Okay, the next one here was one that we found out that the 5 to the 4th power happens to be 625 in the last chapter, or last section, I should say. So here I'm going to separate these two. I'm going to get the 4th root of 625, which is 5, and then I have the 4th root of y to the 3rd power. So it's 5y to the 3/4 power. And then down here, number 32, I have the square root of 36x. I know that the square root of 36 is 6. And for me to write the exponential form in the variable, I take x to the 1/2 power. This one, 33, is a simple one. All you have to do is take the 4th root and the 3rd power. You're going to get x to the 3/4 power, not a hard one at all. And then on this one, you have to make sure that you find the cube root of 8, which everybody here should know by now is 2. We've been working on this one, this particular example over and over and over in this chapter. They seem to like to use 2 a lot. That way the kids don't, the students don't have to use their calculator every single time. And then you have the cube root of b to the 5th, so you're going to take 2 times b to the 5 over 3rd power. And then 37 is where we jumped and we have to make things look like in the radical form. So I have x to the 3/4 power times x to the 1/2 power, and it equals x to the 5/4 power. Now, how did I solve that? Here's my fraction work. You can see that at 3/4 plus 1/2. I know that I have to change that denominator to a 4, so I'm going to multiply the 1/2 by 1, which happens to be 2 over 2. 2 over 2 is the same as 1. Remember your identity property for multiplication, a times 1 equals a, or anything multiplied by 1 equals itself. I changed the 1 to 2 over 2, so I can multiply the top and bottom, and I end up getting 3 over 4 plus 2 over 4, which equals 5 over 4 when you add the numerators together. So then I take the exponential form, which we've already learned, to change it to the radical form, and I get the 4th root x to the 5th. And then I have a similar thing here down here where I have to add the fractions together, and I did the fraction work. Kind of wanted to show you 2/3 plus 1/4. You can see I both of the denominators, you kind of have to multiply the denominators, the numbers for the denominators, top and bottom on each side to get 12, because there's not a really least common multiple there. It's going to be a higher number. And you can see what I did. I took 2/3 times 4 and 1/4 times 3. Sorry about the mess there. And I ended up getting 8 over 12 plus 3 over 12, which equals 11 over 12. And that's where I got that answer from. And then I just wrote it in the radical form, which most of you kids are starting to understand, or students are starting to understand how to do it. Now this one here on 39 is kind of tricky because you have to make sure that you have the 1/2 power to c and d. So I expanded that out, and I realized that I had d, the same base as d times d. I can add the exponents together. So I have 1/2 plus 1/3, use my identity property, and then I multiplied everything through, and I ended up getting 3 to the 6 plus 2 to the 6, which equals 5 to the 6th power, which is how I got that radical form there. So I see c is 1/2, and then d, you see that, is going to be the 6th root of d to the 5th power. Now on 40 here, we have parentheses on both of these. I'm going to take the constants, which is 3 and 8, and put them together. And then I'm going to put together the x's, and I see that that's a fraction. Here's my fraction work. You can see what I did. I'm running out of time, so I'm kind of going to go a little faster here. So I have 1/3 plus 6 over 3 equals 7/3, and then you can see that 3 times 8 is 24, x to the 7/3 power, which equals 24 to the cube root of x to the 7th power. And then we have here 41, same type of thing. I have to make sure that the exponents are throughout the constant and the variable. So you can see how I expanded that out. And then I know that the square root, I wrote down here, the square root of 36 is 6, and the square root of 49 is 7, because I just wrote it in the radical form. And then I know that if I add 1/2 plus 1/2 for the x's, see the x values there both have 1/2 power. I added them together, and that's going to equal 1. So I'm going to have 6 times 7x, and that equals 42x. And then the last one here that we did was we had our x values, we wanted to put them together, so I kind of rewrote it. And I see all the way to x that I think there's a mistake here on 42. I'll have to look. Oh, I'm sorry. That 1/3 there, right there, sorry, should be on the outside, not the inside. It should be in the inside of the parentheses. So I'm sorry, guys. That should be on the outside here. That is my mistake. So I have to make sure that I find the cube root of 8, which happens to be 2, and the x to the 2/3 multiplied x to the 1/3. I'm just going to add those together. It equals 1. The cube root of 8 is 2, and I get 2x. So again, guys, that 1/3 right there, everybody see that? That should be on the outside of the parentheses, not on the inside. So I apologize. I wish I had a pen, I'd change it. And that is your homework assignment. Let me do a long one here too. And that is it. I will see you guys in class.